Okay, chapter 11, welcome to the wonderful world of probability and statistics. Okay, so a lot of reading here. Let me just get some notes written down. So, sample space as sets. Probability is often defined as how likely something's going to happen. Hard to fit that all in. Okay? So when you say this is probably going to happen, you're talking about the likelihood that I think it will or it won't. In determining how likely something is to happen, we must first determine what the total number of things that could happen for any given event or experiment. The list of all the possible outcomes is called the sample space. Okay, so if you're going to ask someone on a date, what's the sample space? Yes, no, maybe. Okay, those are all the possible, I guess, are more possible answers, but those are the reasonable possible answers. Next, a list. There's a lot of vocabulary here at first. The sample space is often organized into a set of elements. For example, the sample space for rolling a die is 1, 2, 3, 4, 5, 6. Flipping a coin, heads or tails. These two sample spaces represent uniform probability. Uniform probability is where each element of the set has the same chance of happening, or in other words, each element is equally likely to happen. If you think of, instead of a Scrabble game, there's not one of each letter in there. Some letters there are more of than others. That's not uniform. Or if I have a bunch of marbles in a bag of different colors, but I have 6 of one color, 5 of another, 2 of another, that's not uniform. But if I had 6 red, 6 blue, 6 yellow, that would be uniform. So in uniform probability, the number of elements in the set is the total number of outcomes. Possible for the sample space. Okay, so like I just said, some are not uniform. I just gave some examples of that. You don't have as much chance of getting a green as you do a red, because there's more red than green. Now, while there are only 2 elements listed in the sample space, red or green, right, the number of outcomes is 3. Because red has 2 and green has 1. So there's 2 outcomes. There's 2 things in the sample space, but the number of outcomes is 3. The notation NS, right here, refers to the total number of outcomes possible in the set. Also notice when we list the elements of a set, we use brackets and separate by a comma. Okay? 1234 is a set containing only 2 elements, whereas 1, 2, 3, 4 has 4 elements. So the commas are important. Okay, so some usual things you'll see in statistics class that we talk about. Flipping a coin. What are the sample space? Well, heads or tails. I can spell, I really can. And we use a brace, and that's uniform. There's only 2 sides, 1 of each. Sample space rolling a die, again, 1, 2, 3, 4, 5, 6. Brace, and it's also uniform. The sample space here, and I'm just going to use letter abbreviations, red, yellow, green, and blue. And since they're all the same size, they're all 1/4 of the circle, that is also uniform. Now, if I I had something like that, the sample space would still be red, yellow, green, and blue, but this would be not uniform. Because the samples, each one is not the same size. Oh yeah, sample space in this last example, well, we have 4s. Well, we have 1 4. We have some 5s. I put an extra comma in there. And we have some 6s. It's not uniform. The reason it's not uniform is because there's 1, 2, 3 6s. There's 2 5s and only 1 4. So you have a better chance of getting 6 than 5 or 4, and you have a better chance of a 5 than a 4. Okay, picking a flavor of ice cream. Sample space. I'm going to abbreviate. Chocolate, vanilla, and strawberry. It's uniform. One of each. Gender here, boy, girl. Uniform. And the sample space here, well, we have some reds and we have some blues. Not uniform. Why is that? There's 4 reds and only 2 blues. Now, you can have larger ones like a deck of cards. Cards are used a lot in statistics. So there are 4 suits. And those of you who are not used to cards, you might want to write these down. Okay? There's a spade, club, those are our 2 black ones, diamond, and hearts. Okay? So there's 4 suits. There are 13 of each card. Ace counts as 1, and this is kind of like 11, 12, and 13 for the Jack, Queen, King. So there's 13 of each suit, 4 suits, that's 52 cards. So large sample spaces can make listing them a daunting task and often quite inefficient. So for this reason, we have a few other ways to organize sample space. Okay? One is a tree diagram. So the first tree diagram you're going to see below, well, the next page, is 2 flips of a coin. The first flip could be a head or a tail. The second could be a head or a tail. And the tree displays the sample space for flipping a coin twice. Heads, 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 tails. Tails, heads, tails, tails. So we're going to jump ahead to that. So first off, you have your first toss. Head, tail. Okay? And then the second toss, you give us a heads or a tails. And here we're going to have a heads or a tails. We're only flipping it twice, so here's our outcome. Heads, 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 tails, tails, heads, and tails, tails, which is what we referred to on the previous page right here. Okay, now the next one, next to it, is going to be 2 scoops of ice cream with the choices of vanilla, chocolate, or strawberry. And again, we're just doing 2 scoops. So on our first try, we have vanilla. First scoop, chocolate. First scoop, strawberry. Now remember, that's our first scoop. Now, with the vanilla, my second scoop, I could have another vanilla, strawberry on top of the vanilla. Or I could go chocolate, vanilla, chocolate, 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 strawberry. Strawberry, vanilla, strawberry, chocolate, strawberry, strawberry. That's my second scoop. So what does that give me for my choices? Vanilla, 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 chocolate, vanilla, strawberry. Chocolate, vanilla, chocolate, 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 strawberry. Strawberry, vanilla, strawberry, chocolate, strawberry, strawberry, which we refer to back here. Those are our choices. Now you might say, well, aren't these two the same? Well, they're the same flavors, but you're eating them in a different order. So one you're going to eat the chocolate first and the vanilla, and the other you're going to have vanilla and chocolate. That's a different experience. That's a different look. Now you can also do a table or chart. A tree diagram would probably not be the best way to organize the sample space for all the possible outcomes when rolling two dice. This would create a very large and a hard to draw tree diagram. A better way to organize it is a table. So if I roll 1, then a 1, I roll 1, then a 2, a 1, then a 3, and so forth. I'm just going to hit pause and you can fill this out. Wasn't that fun? Okay, so those are all the possibilities. Now once again, you can say, well, aren't these two the same? Yeah, they are. If you're playing a game where you're just rolling the dice, like Monopoly, that's a 3. Doesn't matter which dice it is. But let's say, this was a red die and this was a green die. Well then, a 1 on red and a 2 on green is going to look different than a 2 on red and a 1 on green. So it still is a different outcome, even though they add up to the same number. Just like the ice cream. Chocolate, vanilla, vanilla, chocolate, same combination, but a different order and a different experience. Okay, so when dealing with the occurrence of more than one event or activity, such as this one, it's important to quickly determine how many possible outcomes there are. So in this one, we could do 6 by 6 to get 36, right? 6 rows by 6 rows. This is called the fundamental counting principle. And this makes life a lot easier. So, if there are A ways for one event and B ways for the other event, there's A times B for both to occur. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So, here we go. Club Restaurant offers 6 appetizers and 14 main courses. What's the sample space of a person who orders 1 appetizer and 1 main course? Well, think about it. If we were going to do a tree diagram, we have to do 1, 2, 3, 4, 5, 6. And then we have to do 14 here and 14 here. That's a messy tree diagram. And it'd be a big table. We don't have to do that. We just have to take 6 of this times 14 of this equals 84 possible outcomes. A coin is flipped. 2 choices there. A die is rolled. 6 choices there. A card is picked from a deck. 52 choices there. It helps identify the numbers like that. Then all you do is multiply them. That's 624 different combinations of a heads or tails, 1 through 6, and all the different cards. Number 3, the pass lock on an iPod, it requires 4 digits. What is the sample space for all 4-digit passcodes? Well, you got to think about that. 1, 2, 3, 4. Here's the numbers. How many numbers can go in the first spot? A lot of people will say 9. So you can't forget the 0. There's 10 numbers there, 10 here, 10 here, and 10 here. You got to multiply all those to get 10,000 different possibilities. Jeff has 5 t-shirts, 3 pants, and 4 pairs of shoes. What's the possible sample space for all of his outfits? Again, a tree diagram here would be really messy. All we have to do is 5 times 3 times 4. which is 60 different possible outfits. We don't really care if they match or not, or they go together. That's all we need to know. And that's it.